Welcome and settle in as we drift below the surface of a quiet channel to visit the tranquil duty of a tidal turbine, turning slowly with the patient rhythm of the moon. If this gentle journey helps you relax, you can softly tap like and subscribe. And you might enjoy the playlist link in the description to keep learning while drifting off. How sleepy are you on a scale of 1 to 10? Imagine yourself finding a comfortable place, feeling the weight of blankets settle like a calm tide over your shoulders. The room is dim and steady. Your breathing lengthens. The world narrows to soft sounds and slow thoughts. In your mind's eye, you wander toward a shore at dusk where the horizon is a band of cool gray and silver, and the sea is a broad mirror that rises and falls without hurry. The air is mild with salt and the faint sweetness of kelp, and somewhere far away, a buoy bell marks time with a soft and friendly ring. The tide moves in its ancient cycle, and beneath the surface, a machine waits and turns, working with almost no footprint on your awareness, almost no need for attention, like a steady heartbeat that you notice only when you choose to listen. This is the world of a tidal turbine. It is a gentle relative of the wind turbine, adapted to the dense, silky flow of seawater. Picture a smooth nacelle shaped like a streamlined seed, with blades that are slightly curved to coax energy from the current. Unlike wind turbines that sway and sing on tall towers, this turbine sits under the waves, shielded from gusts and storms by the quieting blanket of water. It rests on a foundation that looks simple from a distance, a clean geometry of steel or concrete anchored to the seabed's patient gravity, and it performs a humble task with grace. It turns when the tide turns it, and when the tide pauses, it rests. You can imagine the ebb and flow passing by. The water is not rushing at all. It moves with steady insistence, like a slow breath. The turbine meets this flow with a welcoming posture, its blades angled to catch the stream, much like the wing of a seabird set to glide. The motion is smooth and continuous, the pace unhurried. As the blade arcs by, the water wraps around it in a clean laminar embrace that can become gently turbulent as it releases into a soft wake downstream. If you listen carefully down there, there is a nearly inaudible hum from the generator inside the nacelle, a sound softened and filtered by the thick water and the cushion of distance, until it becomes little more than a suggestion in the ear, something your mind files under gentle, unremarkable, safe. Tidal currents are born of a quiet celestial choreography. The moon pulls on Earth's oceans, and the sun joins in. And the spin of the planet shapes the path of the water through basins and straits. In some channels, where the sea must slide around a headland or squeeze between islands, the movement of water gathers into a strong, reliable flow. Engineers call this predictable kinetic energy a resource, but the phrase feels small beside the image of Earth and Moon tugging softly at each other across the sky. The result down here at human scale is a current that comes and goes on a schedule so steady that it can be charted centuries in advance, a tempo that never rushes to surprise. The predictability is a comfort. If you let your thoughts drift, you can picture a simple calendar of the sea, a quiet ledger of morning tides and evening tides, springs and neaps, the rising and falling of the range as the lunar phases glide through their cycle. When the new moon and the full moon line up with the sun, the tides are a little stronger. In the first and last quarter, they are gentler. The turbine waits, patient either way. It does not mind stronger or gentler, only that the current arrives. The gentle rhythm continues. Inside the turbine, the physics is a thoughtful arrangement of simple ideas. A fluid flowing past a blade exerts force. The blade is shaped to be a hydrofoil, a smooth profile that lifts in the stream. The angle is tuned so that the lift generates a torque around the hub, and the torque turns the shaft. From the shaft, the motion becomes electricity. Sometimes a gearbox sits between the slow-turning rotor and a faster generator, and sometimes, to make things simpler and sturdier, the machine uses a direct drive generator with powerful permanent magnets. In either case, the interior is sealed from seawater and carefully filled with components that like peace and clean spaces. Bearings put in their housings. Seals keep the ocean outside where it belongs. There is oil in some designs, and in others there are water-lubricated bearings that sip the sea through filters so delicate that very little else is invited in. Everything is arranged to prefer long stretches of quiet, low-maintenance service in harmony with the schedule of the tides. The blades are built to resist a whispering specter called cavitation. Cavitation is the formation of tiny vapor bubbles when pressure drops too low around a fast-spinning edge. In air, a blade can be sharp and light. Underwater, designers want gentler loading and less extreme tip speed. The tips do not slash at the water. They pass through it with measured grace, and the pressure stays kind, so the water remains liquid and whole. This is why the blades look a bit thicker than their cousins above the waves, and why the turbine turns more slowly than wind farm towers. With seawater almost 800 times denser than air, the energy in a slow tidal current can be quietly abundant. This density is a friend because the turbine can be modest in size, yet the currents still carry enough strength to turn it faithfully. Above the waterline, people sometimes forget how tranquil the seafloor can feel when the weather is rough at the surface. Waves break and wind whistles, while down below, a turbine continues its slow duty, shielded by the column of water. The sea filters high-frequency commotion like a heavy curtain dampening a room. The machine keeps turning, steady and unbiased. When the tide slackens, it rests. Imagine yourself floating now, buoyant and safe, seeing the turbine waiting for the next push, just as you wait for your next breath. The gentle rhythm continues. Engineers place tidal turbines in a few ways. Some sit on gravity bases, which are sheer body, and heavy bids that rest on the seabed without drilling. Others are fixed on monopiles driven into the sediment or rock like quiet pillars. In deeper, swifter waters, some turbines hang from floating platforms moored with chains to anchors, finding a stable equilibrium between buoyancy and tension, always aligning to the flow like a kite held steady in the wind. There are also tidal kites, which follow a graceful figure-8 path under the surface, moving a smaller turbine through water faster than the background current, yielding energy through gentle choreography. No matter the approach, the guiding aim is the same: to work with the water rather than against it, to keep forms simple, to keep motions slow and understood. Power that is made underwater must travel to land. From the nacelle, cables descend along the structure, then follow the seabed to shore through a trench or a gentle burial. If you trace the route in your imagination, it passes through a garden of cold emerald seagrass, over patches of clean sand that ripple like the soft lines of a sleeping face, past stones dusted with fine silt where crabs make tiny patient paths. The cable is an artery for quiet electricity wrapped in layers of insulation and armor, sometimes with steel wires wound around it like a patient braid, each wire coated and protected. Where cables meet, elegant connectors are mated by divers or remotely operated vehicles in planned visits that happen in calm windows when the tide moves slowly. On shore, a modest building houses equipment that smooths, synchronizes, and conveys the energy to the grid, joining a wider community of kilowatts and megawatts, traveling to lights and kitchens and warm rooms where people rest. The myth of the sea as wild is true at times, but the daily reality around a tidal turbine feels more like the steady hum of a sleeping house. The ocean makes its own soft noises. Shrimp snap, fish whispering across current make minute patterns of sound. Kelp rubs kelp. A distant ship is a low and fading thrumming. The turbine adds a tone that hardly rises above the chorus. Environmental teams measure that tone, record it, learn it, and design so that creatures that share this water continue their own routines with ease. It is a quiet place to begin with, and it remains quiet by intention. If you picture the life cycle of a tidal turbine, it unfolds in peaceful chapters. First, people study maps of the seabed and maps of the current, watching the lines that show speed and direction, watching how these lines bend around headlands and narrow between islands. Acoustic Doppler current profilers sit in the flow for months, recording gentle pulses that reveal the heartbeat of the channel. The data come back to land with the patience of a message in a bottle, not rushed, drawn by tide cycles and ship schedules. Engineers feed this data into models, and the models speak with a calm voice about how a turbine would experience the world there. They talk of turbulence that is gentle or rough, of speeds that press the blades with this or that strength, of the spacing between machines so that each one may breathe and spin without unkind wake from its neighbor. When the site is chosen, the foundations are placed. Perhaps a jack-up platform stands steady on its legs, lifting out of the water so that cranes can move slowly without roll. The pile is lowered and installed with the measured cadence of a metronome. The vessel crew follows the flow's schedule, working more when the tide slackens and pausing when the current is strong, never fighting when patience would be simpler. You can imagine gloved hands passing tools, quiet radio voices, the smell of warm diesel in the cold, salt air, and the shudder of machinery felt as a gentle tremor through boots. Then suddenly calm, the work sets and cures, and the structure rests with the same stillness as a rock on the seabed, waiting. The turbine arrives and is attached with the same unhurried care. Wet mate connectors couple with steady pressure. Locking pins slide into place. The nacelle, bladed and whole, comes to life when the tide returns. In the control room on shore, screens glow with tidy graphs. There is torque and speed, temperature and vibration, voltage and power. The lines pulse with the tide, rising and falling as the current comes and goes. Someone watches, absorbed in the texture of normal operation, almost lulled by the regularity. They listen to the numbers like a soft melody, ready to notice if any note strays. As you listen now, you might sense gravity in a new way. The moon's pull is gentle but firm, and it travels into your room as a schedule rather than a weight. Tidal curves march across a calendar and across your breathing, the same patient cadence. Twice a day, usually, the water flows one way, and twice a day, it reverses. There is a grand bass note called the semi-diurnal tide, and a subtle harmony when the diurnal components rise a little in strength. Names like M2 and S2, K1 and O1 sound technical, but each is simply a thread in the woven cloth of the sea's rhythm. Engineers use these threads to forecast the power of a site. The result is a template of time that wears smooth edges like stones in a shoal. It is reassuring to imagine how long this has been true, how long it will remain true. There is a gentle history behind all this, too. Long before underwater turbines, people built tidal mills in quiet inlets with stone walls holding back the sea. At high tide, gates would open and water would fill the mill pond. As the tide fell, the stored water would be released through a wheel, turning millstones with the pace of a slow song. You can still visit some of these places where the wood has silvered and the masonry has settled into the landscape like an old friend's shoulder. The principle was the same. The ocean would not be forced. It would be invited, and then it would give back what it could, calmly. The present machines are more efficient and more subtle, but this fundamental sense of gentle partnership has not changed. Imagine yourself drifting underwater beside the turbine. There is no hurry. The light is dim and green, and particles drift in the flow, catching the light like tiny stars. A fish passes unalarmed, moving with casual skill, as if the current were a soft treadmill and the fish a slow pedestrian. The turbine turns without drama, the edges of the blades rounding away from the camera of your mind the way a hand moves past your cheek in a gesture of reassurance. Everything is at peace. The gentle rhythm continues. Materials are chosen for the long, salty life they must live. Coatings keep steel from giving itself back to the sea. Sacrificial anodes of zinc or aluminum do the polite work of wearing down in place of the turbine, offering themselves so that the structure remains smooth and intact. Stainless steels and composites, carefully layered and cured, resist the bite of chloride ions that always want to nibble. Engineers think about these details when most of us are looking the other way. They choose paints that resist biofouling. They plan for easy cleaning. When the time comes, a remotely operated vehicle glides down with soft thrusters and brushes away a beard of algae with the slow persistence of a gardener tending a stone wall. Above the turbine, the surface carries its own moments. Sometimes there is a glassy calm that feels like the world holding its breath. Sometimes gentle ripples pattern themselves like drowsy thoughts, spreading and fading without any urgency. On rare days, whitecaps pass, hurrying to somewhere else, and the turbine does not concern itself because the current is the true keeper of its schedule. Ebb, slack, flood, slack. The blade angles itself for each phase without complaint. Some turbines set to a symmetrical profile that can turn one way and then the other without fuss, the way a symphony repeats a theme. Grid connection feels, from the turbine's point of view, like a handshake with a distant friend. The power electronics do the careful work of matching phase and frequency so that each electron joins the wider current on land in smooth step. Voltage may be transformed in a small onshore building with a low roof and walls that hold the quiet hum inside. There is often a small yard of gravel and a simple fence. Perhaps there is a single lamp post that glows at twilight, a soft pool of warm light in a landscape of gray stone and green grass, a sign that human activity is present but not intrusive. Around a tidal array, ecological life continues its routines. Mammals pass by with their own schedules. In many places, seals haul out on rocks and then slip back into the water, as plump and curious as ever, finding the turbine a mundane object in their neighborhood. Porpoises travel through in arcs and arcs, soundless to our ears. Fish choose paths between blade sweeps with an ease that reminds us they are built for this world. Studies are done to watch these patterns, not in search of drama, but in search of understanding, so that designs can be tuned and placements can be adjusted if any subtle harm would be avoided. Over time, a turbine may even become a small reef, a focus for life in a patch of otherwise plain sediment, because surfaces invite settlement. These are often unremarked changes, which is a compliment in environments where quiet continuity is the goal. The turbine's controller wakes and rests with dependable behavior. There is a cut-in speed where the current is strong enough to turn the rotor usefully. Below that speed, it sleeps, not wasting effort. There is a pitch schedule that aligns blade angle to the current. There are limits that keep everything comfortable, ensuring no component is stressed beyond a calm tolerance. If the tide ever runs fast on a spring day, the turbine knows how to feather its blades a little more to keep within its familiar hum. In all of this, a sense of courtesy prevails, courtesy to the water and courtesy to the machine itself. You can imagine a night watch in an operations center when the tide is rising. One person sits with a mug that has cooled to a tolerable warmth, reading the harmonics of the flows from a blue-lit screen. Graphs drift up and down like lullabies. An alarm test bings softly, predictable and friendly. Outside, a light breeze moves through grasses, and a small generator hums, and the sky flows with the weightless movement of thin clouds. The person checks seals on the screen, watches oil temperatures, nods at currents, and then looks out the window at the dark sea where the turbines perform their unobserved duty. In that moment, the machines feel like a crew that does not need constant supervision, trustworthy and content to keep working without applause. Tidal energy is often placed in a constellation of other renewables. Because the tides are so predictable, they can complement wind and solar with a timing that fills gaps. On a sunny day with little wind, the tide may be running. On a windy night, perhaps a slack tide gives the turbines a rest. Energy modelers love this geometry of time. They arrange it in studies that read like poetry to those who listen, with words like complement and smoothing and diversity. The more you think of it, the more it resembles the orchestration of sleep hygiene in a home. Dim the lights, quiet the noise, slow the pace, and everything finds a composure that helps rest happen on schedule. The gentle rhythm continues. Sometimes the details of hydrodynamics come to mind, and even these can be soothing when presented with kindness. Flow separation is a small drama avoided by good blade shapes so the water does not peel away into vortices too early. The tip-speed ratio is chosen to make efficient use of energy without insult to pressures. The blockage effect in a narrow channel can raise the local speed slightly like the way blowing over the lip of a bottle makes air hurry. Designers use careful equations for these effects not to impress, but to understand and make things simpler. They paint a signal image with these numbers, and then they choose something conservative, something that errs on the side of quiet operation. The machine then spends its days within a safe, soft envelope, just as a person might stay under a blanket at a comfortable temperature, breathing within a range that feels easy. Imagine the turbine's world as seasons pass. In spring, the water is cool and clear, and plankton blooms into gentle clouds. In summer, the water warms a bit, and fish are plentiful, and the blades accumulate a subtle film of life that is later brushed away in a planned visit. In autumn, storms march at the surface, while the turbine's interior remains warm and constant, a little island of steadiness. In winter, the water is crisp, and the currents may bite more sharply, but even then the schedule is the same. All the while, the turbine turns and rests, with the same patient character. You can imagine the comfort that comes from routines at home, how the familiar route from bed to kitchen is reassuring in the dark. The turbine knows its simple path in a similar way. The energy produced is not a spectacle. It is a dependable fraction added to a quiet total. Over weeks and months, meter readings accumulate like grains of sand in a glass, adding up to warmth in houses and light by chairs, to induction stoves sighing and kettles whispering and laptops charging on desks where someone writes a letter. The turbine does not need thanks. It is enough that the current runs and the blades spin and the electrons go where they are needed. When arrays are built, spacing follows the logic of water's restlessness. Wakes behind turbines are gentle regions of slower, more agitated flow. If machines were packed too close, they would share turbulence the way too many people in a room share heat. Instead, engineers lay out rows and columns with a comfortable distance, allowing downstream water to recover before meeting the next blade. In a flood tide, the wakes reach in one direction. In an ebb tide, they point the other way. The plan respects this dance, laying out an underwater orchard where each tree has enough light and air. The image of an orchard is fitting, it is neat, it is human, and it reminds us how simple, well-spaced patterns can feel peaceful to the eye and to the current. Sometimes a tidal project uses a floating platform moored with lines that descend in a patient catenary to anchors resting on the seabed. The platform rises and falls with the waves while the turbine beneath hangs at a steady depth where the current is strongest and the motion of the surface is diminished. The whole assembly aligns with the flow, nose into the stream, much like a boat at anchor that always points the same way. The mooring lines creak softly in a windless memory only in your mind, because underwater they are silent and dependable. Acoustic beacons may mark their positions so that passing vessels know the shape of the field, and navigation lights blink with the pace of maritime conventions. The colors are subdued. The steel is unpainted in places where paint is not needed, a practical gray darkened by spray. The message from these structures is not to amaze, but to quietly indicate the presence of useful work done out of sight. Underwater lanterns of bioluminescence are sometimes seen on night dives, tiny pinpricks of living light stirred by a hand or a fin. It is easy to imagine such a glow in the wake of a blade, small and gentle, like embers lifted from a fire, but cool, not hot, and living, not burned. The reality is often less dramatic, yet the thought of life responding to flow reminds us that the sea is full of small interactions that rarely trouble one another. The turbine is just another participant in a great patient conversation started long before us. In places like the Pentland Firth between mainland Scotland and the Orkney Islands, the water draws itself fast through a narrow turning strait that has carried tides since before memory. In Bay of Fundy, the range is great, and the motion of water is a grand, slow motion that can be felt in the bones of the coast. In Strangford Lough, people watched one of the first modern tidal turbines turn under a channel where seabirds fold and unfold the air with lazy strokes. These sights are not famous to all, and they do not need to be, because they belong most of all to the communities who live beside them and to the quiet loops of the tides themselves. You might picture the scheduling around maintenance. The turbine invites a visitor only when the tide is at ease. Remotely operated vehicles descend with calm, purposeful movements, their thrusters whirring like purring machines. They hover beside the nacelle for close looks, their cameras capturing the small patterns of life that have settled on the structure, and the telling signs of wear or the satisfying absence of wear. If something small needs attention, a plan is made for the next slack water when a tool can be guided into place without resistance. The work is like needlepoint, deliberate and careful, forming a pattern of tiny actions that together maintain the tapestry of operation. The gentle rhythm continues. There is beauty in the maps that predict tides. Harmonic constituents are combined, each a sine wave with its own period and amplitude and phase, each a friendly expression in a drawing that becomes more faithful with each added term. A few are enough for intuition. More are available for precision. The maps are shaded with colors that move in daily animations, changing with the turn of celestial gears. Everything is knowable here in a way that gives comfort, because even the complications are well behaved with time. Few things are as predictable. Few rhythms are so patient. The interior of the turbine stays dry. Humidity is controlled. Temperatures are moderated by the water outside and by exchange systems inside. Electronics that measure and actuate are kept in conditions they prefer. Soft gaskets are torqued to values chosen after testing. Bolts are checked for tension. When a hatch is opened, perhaps once a year, the smell is a faint blend of lubricants and metal, a scent of quiet industry, not sweaty or harsh, but as if a machine room had learned to be a library. Tools are set on mats that do not rattle. Knotted ropes are coiled and labels are clear. It all reflects human care and human attention to the almost meditative quality of good maintenance. Before the turbine was installed, environmental surveys observed the seafloor with sonar that paints pictures from echoes. The images looked like blurred photographs of ripples and boulders, kelp groves and sand. Bathymetric lines traced the contours like the contours of a sleeping landscape, with cliffs and plains and slopes that repeat nothing dramatic. When the time came to place the structure, the chosen spot rested on firm ground, with no ancient shipwreck or living reef to disturb, surrounded by plenty of open current. The same surveys will be repeated to watch for changes. If the seabed scours a little around the foundation, the fix is simple and modest, perhaps a scatter of rock to armor the bottom, a natural look. The guiding principle in all of this is to keep the sea, as much as possible, as it has always been. When people talk about the cost of tidal energy, they speak in measured tones. At first, prototypes are expensive because innovation always asks for trial and revision and patience. As designs converge and production repeats, costs settle down. Remote monitoring reduces the number of boat trips, improve materials, lengthen intervals between inspections. Standardization makes connectors modular and tools universal. Learning curves do their quiet work until the technology looks less like an experiment and more like the machinery of daily life. The economics follow this soft descent, and the conversation becomes less about price and more about value, about the companionship of predictability in a system full of variables. Integration with coastal communities is gentle. A small substation among gray buildings and green fields, a pier that extends the memory of past fishing and future ferries, a few warning signs that blend into the maritime language of the place, conversations at town halls where concerns are heard, and at kitchen tables where a parent explains to a curious child that invisible turbines turn under the water and help power the lamp at bedtime. For the child, this thought might be slightly magical. Machines working while the household sleeps, guided by the moon, seems like a fairy tale that is true. The gentle rhythm continues. As you rest, imagine your senses tuning themselves to the soft physics of the channel. Place your mind right at the hub of the turbine where the rotation is slowest, where the blades are anchored and the movement is steady and small. From there, feel the torque, not as a jolt, but as a quiet push that never ends until slack water, like someone telling a story in a low voice, calm and unbroken. Then when the tide eases, the story pauses. The room is still. The water holds itself for a while, and then, at a time known in tables and felt in bones, the flow resumes in the opposite direction, and the story continues, familiar and comfortable, through the night. In an engineering drawing, a turbine is sliced with thin lines that reveal sections of blade and nacelle, the placement of bearings, and the path of the generator's field. There are dimensions in millimeters and notes that specify surface finishes so fine they almost feel like cloud under a fingertip. These drawings carry their own quiet aesthetic, a language of clarity that tries to leave nothing to chance. The turbines that emerge from these plans carry this clarity into the water. They look the way they must look to be efficient and to be simple, and that necessity has its own elegance. Beneath the narrative of turbines is the grander narrative of tides, which is rooted in gravity and geometry. The Earth is a spinning sphere with an ocean that moves slightly slower and responds to forces that do not change quickly. The moon orbits, the Earth tilts. The sun's influence rises and falls with the lunar cycle, and the continents shape basins that respond with resonances, like musical instruments with body and air. Some places swell a little more because the geometry fits perfectly with the rhythm. Other places hardly swell at all because the geometry cancels much of the pull. Humans discovered these patterns with patience, and then charted them, and then harnessed them, always with the same calm respect for things that are large and reliable. Because water is dense, the power in a given square meter of flowing tide can be surprisingly generous, even at speeds that, to a swimmer, feel like a lazy river. The formula that tells this story places density and the cube of velocity together, which means that slowly rising speed makes quietly outsized contributions to power, and that design choices that lower speed a little to avoid cavitation still leave ample energy to harvest. The message from the math is to be gentle and careful, and the yield will still be worthwhile. It is another reason why the machines turn as slowly as they do. The result is a turbine that may complete only a small number of revolutions per minute, a pace that aligns with the measured dominant tempo of the sea and the subdued tone of this bedtime rumination. From time to time, storms will pass overhead, drawing scrolls of cloud across the horizon, bringing rain that scratches the surface of the water. The turbine feels these changes less than any boat or buoy. Waves die with depth, and the current remains. The machine continues its work, indifferent to the spectacle above, pulled only by gravity's quiet hand. The gentle rhythm continues. Life gathers in shadows and niches. In the eddy behind the foundation, there may be a patch where sand accumulates. Small creatures make homes there. A starfish traces a patient route over pebbles. A mussel colony colonizes a corner in an unplanned but tolerated way. The turbine's presence adds a little structure in a place that had less, and structure invites life. The relationship is unassuming, without drama, simply part of the world now. On land, the presence of tidal energy takes a soft shape in the electrical system. Operators plan for when to expect more power from the sea and when to expect less. Storage systems can be charged or discharged accordingly. Schedules can be arranged. This is the kind of predictability that people who manage complex systems treasure. It is the kind of predictability you might seek in your own life when you set a bedtime, dim a screen, and let a familiar routine guide you toward rest. Imagine the voices of the people who build and maintain these projects. They speak to one another in practical phrases, but there is a pride that has no sharp edges. A welder describes the clean bead that sealed a seam. A diver talks about visibility and currents, and the satisfaction of connecting a cable first try. A software engineer explains how a small update brought calmer pitch adjustments that reduce fatigue loads, like smoothing a wrinkle in a sheet. Each of these small victories is part of the long, peaceful life of the turbine. None calls for excitement. Each calls for a nod and a quiet smile. It is time now to visit the control logic again, not to solve, but to appreciate. Controllers sense blade loads and adjust pitch to keep the machine at an optimal tip speed ratio, staying within limits that protect materials. If a sudden swirl passes, maybe from a tidally generated eddy, the controller sees a transient in torque and gently compensates, then returns to normal. If a sensor registers an abnormal vibration, the turbine may feather its blades and wait for human inspection. Safety is soft and instinctive here. Rest is not failure. Rest is part of the design. You might enjoy imagining an underwater corridor where multiple turbines stand at intervals. In ebb tide, the corridor is a gallery of turning forms, all synchronized by the same slow metronome. In flood tide, the gallery reverses. The water mass that passes through is vast and indifferent to our small machines, and yet the machines touch only a fraction of it, taking what they need with a compact gesture and leaving the rest unperturbed. The wake plumes trail like silk scarves in the current, and then visible only in the mind, they vanish into the wider flow. On shore, the small substation emits a hum that is felt more than heard. It is the sound a cat might pick out while sleeping and then forget. Transformers rest in enclosures that look like tidy boxes. Names and numbers are stenciled on doors. A pair of gulls sits on a railing. Grass grows along the base. Inside temperatures are monitored. If a fan turns on, it does so with a measured spin. There are charts on clipboards that match charts on screens. A calendar shows weeks marked not by holidays but by spring tides, and neap tides not by deadlines but by windows of low current when a visit offshore will be easiest. A remarkable thing about tidal technology is how the loudest part of its story is almost always the sea itself. And when the turbine is new and cameras and journalists come to watch from a distance, the surroundings absorb the attention. The water is more captivating than the machine, the sky more present than the generator. This is as it should be. The turbine is a guest in this world, a careful guest who keeps to itself, who follows house rules, who cleans up after itself, who brings a modest contribution to the nightly bill for light and heat, and then retires without fuss. And when the turbine's day is finally done, many years from now, disassembly is a reversal of installation, measured and unhurried. Pieces come up and are taken ashore. Surfaces are cleaned and sorted. Metals are recycled. Sites are restored. If a better turbine returns to the spot, the foundations might be reused with quiet thrift. If not, the sea resumes its habit without interruption. The scene is much as it was, and the memory that remains is local and affectionate and not overly dramatic, like remembering a soft-spoken neighbor. Imagine yourself now on a small vessel at dawn. The deck is damp with dew and the air is cool in your lungs. The horizon is a gentle line. An engineer checks a list on a clipboard and looks at the water. The tide is easing toward slack. Today, they will lift a turbine for inspection and return it by afternoon. The operation is slow, the movement small. A crane arm swings with careful control. The crew speaks in low voices. The clink of a shackle against a steel deck is unhurried. You lean on the rail and feel the stability of the boat in a mild swell. You watch as the nacelle emerges, beads of water running from its smooth skin like dew from a leaf. It rests, shines, and then descends again to its place. It is like a breath in and a breath out. The gentle rhythm continues. At many research centers, there is a patient culture. Instruments are calibrated with ritual care. Data logs are double-checked. Field notes are written by hand and later transcribed, then archived. When results are presented, the tone is thoughtful. Interpretations are cautious and built on that quiet confidence that the tide is trustworthy and the machinery is increasingly well understood. Students learn not just the equations, but the temperament that suits this field. Steady, observant willing to wait for the right window, the right condition, the right moment to act. All of this may lull you, and that is the aim. The aim is to let your mind rest on images of water and machinery and gentle cycles. Whenever a detail floats into focus, you can let it drift back out, knowing that nothing urgent is required of you. The turbine takes on a hint of personality, not as a complex character, but as a valued appliance that goes about its day without complaint, content to serve quietly. A tidal turbine's duty is tranquil because the tide is tranquil, at least in its certainty. Even when the water moves swiftly, the schedule is calm, the expectation set by celestial mechanics rather than whim. It is like a clock powered by the weight of the moon, a clock that keeps time even when nobody looks. This metaphor may be an overstatement because a turbine is not an astronomer and the sea does not wear a watch, but it points toward a truth about how safe and contained this energy feels, how unlike a sudden gust or a lightning strike. It is a lullaby you can hum with your eyes closed, confident that the next note will follow, and the next, until sleep comes. The conversation about marine life continues in parallel with the technology. Researchers use cameras and sonar that draw pictures from sound without needing light. These instruments watch fish and mammals and invertebrates living among turbines and foundations, recording long spans of uneventful coexistence. When an interesting moment occurs, such as a school of fish slipping between blade passes or an animal changing course, the data is studied with care. The lessons lead to small adaptations in blade shape or speed limits or spacing, a set of kindly adjustments that refine the accord between machine and environment. This is the slow, thoughtful work of friendship between technology and the sea. One could imagine a far future where clusters of turbines line channels in different parts of the world, each group tuned to local conditions, each contributing a dependable piece to a global grid. The thought is not grandiose. It is simply an extension of placing gentle tools where they can do good without fuss. Islands that once relied on loud diesel may now hear the quieter hush of waterborne power. Coastal towns might look the same, their rhythms unchanged, their nights as calm, while beneath the surface, turbines count out the hours. In your own room, the equivalent might be the quiet fan of a heater, or the barely audible compressor of a refrigerator that hums once in a while, to keep things just so. These sounds recede into the background and become signs of safety rather than distraction. The underwater hum of a tidal turbine is like that. Those who live near them rarely notice them at all. Those who study them do for a time, and then their attention returns to the broader symphony of the ocean, where weather and life perform the louder passages. When planners consider where to put turbines, they choose channels where shipping can navigate around clearly marked areas. They coordinate with fishers about nets and lines and routes. They choose depths that place machines under the drafts of vessels and above the seabed in the strongest flows, a vertical sweet spot where the water has both speed and space. In this negotiation, signs and lights and charts carry more weight than words. A lighthouse still serves as a symbol bright and calm, assuring all that the coast is cared for. Suppose the turbine could speak. It would say very little. It would ask for clean bearings, secure bolts, and a periodic brush to keep its shape fair. It would thank the tide for the push, not with enthusiasm, but with consistent acceptance. It would not ask for praise. It would prefer the company of those who understand that steady work is its own comfort. Then it would resume turning, contented. The predictive charm of tidal energy invites certain practical intricacies. Power curves are mapped to tidal phases. Forecasts are routed into grid operations. Week by week, spring tides deliver a little more and neap tides a little less, in a pattern as soft as the waxing and waning of the moon. The grid, with all its demands and balances, can look forward and make ready. The benefit here is as much psychological as technological. The human operators sleep better when surprises are fewer. The universe of electrons becomes a gently lit hallway rather than a buzzing arcade. During installation, winches pay out lines in smooth arcs. The sound of a drum turning becomes a hypnotic circle of notes. A load floats in the water, buoyed by physics that seems to conspire in your favor while the crew waits for the moment when gravity and buoyancy are in comfortable balance. In that pause, time extends a little, and then a soft nod tells everyone that it is time to proceed. The work is done by many hands, each performing tasks that are fluent through repetition and thoughtful design. Habits are good here. Checklists are good. Ritual is good, not because something dark lurks in the background, but because things feel even quieter when shaped by well-practiced care. You may find that the image of turning blades begins to blur and cross-fade with your breathing and with the movement of your thoughts. This is helpful. Let it. Imagine yourself drifting above the channel high enough to see the sinuous flow. The tide sends streams through narrows where they speed up, around points where they eddy gently, across shallows where they lace with delicate ripples. Underneath, the turbines lie in their anchors like stones in a river, steady, and the currents brush them with unthreatening insistence. From above, the pattern looks like a fabric laid over the sea by a patient hand, threaded by the moon, smoothed by the turning of the earth. Still awake? Comment the secret word nebula. Precision matters in design, and precision can be calming. A bearing clearance of a fraction of a millimeter is chosen after observing how materials expand and contract a little with the temperature. Seal lips, contact shafts with a pressure that is enough to hold out water, but not so much that it generates heat. The ratio of blade chord to radius changes along the span in a way that leaves the tip slim and the root strong. The generator windings carry currents that are modest and well within ratings. Every number finds its place in a bracket marked by safe limits, and the machine then lives its life inside those brackets the way a river lives within its banks. Even floods and neaps do not change this truth because the banks were chosen with those in mind. Consider friction, that ancient companion of motion. Here, friction is a comfort as much as a concern. In bearings, friction is minimized and smoothed with lubrication so that the turning is effortless. In the seabed, the friction between foundation and ground ensures nothing moves that should not. In the cable armor, the friction among wires shares load. Everywhere, friction is something managed, not feared. The net result is a texture of motion that is free where it should be free and secure where it should be secure. Sometimes a turbine is designed with redundancy in mind. 2 sensors for 1 parameter, 2 paths to shut down if needed, 2 seals in sequence. It is not paranoia, it is kindness. It lets the machine continue when one small part decides to rest early. It lets maintenance be scheduled rather than hurried. It lets humans plan their visits around weather and tide and life. The gentle rhythm continues. The places where tidal turbines thrive are often beautiful in ways unrelated to the machines. Cliffs where seabirds nest in chattering colonies, low, patient hills of heather, coves where the water is steel blue in the morning and satin gray in the evening. On winter afternoons, the sun slides low and casts long shadows that the tide shortens and lengthens as if playing with a sundial. The present technology is just another layer in a landscape that already knew how to be calm. Between turbines and shore, sound travels differently than through air. Low frequencies move with ease, high frequencies fade. This is why the underwater world can feel dreamy and vast. A ship far off sends a bass through the body. Waves hiss. Only nearby the turbine adds a tone to this grand music that does not shout. It is a minor hum, a background suggestion, the sound of a transformer in a distant room. The creatures that share this world are, by design, seldom troubled by it. They live their lives, and sometimes they explore, and sometimes they ignore, and the turbine continues turning without asking for attention. Among the small secrets to a turbine's long life is the choice of coatings. Paint may be more sophisticated than it seems, laid in layers that bond tightly to metal, with microscopic textures that discourage barnacles and algae from clinging too well. Some coatings release a tiny film that is non-toxic but slippery, a way of nudging life to settle elsewhere. When biofouling does gather, a scheduled brushing returns surfaces to their intended shapes. The work is quiet. No scrubbing on a deadline, no hurry in places where hurry invites errors. Just a patient sweep, a slow inspection, a return to service. Time feels different near tides. Schedules pivot around slack water because that is when the current grants permission to approach. If you were to spend a week with a maintenance team, you would begin to plan your meals and your sleep around these windows. Breakfast might become late. Lunch might become a snack at an odd hour. There is a calm reason for it, and bodies adapt, and soon the schedule feels natural. The tide decides, the turbine agrees, humans respond. There is a gentle poetry in the cables that connect turbines to shore. Each cable is a quiet bridge that carries no feet and crosses no ravine but spans a realm nonetheless. The electrical stress within its insulation is carefully managed. The copper or aluminum inside is pure and clean. The armor wires take the burden of pulling during installation and then relax into a protective posture for the decades ahead. Even the final landing on shore is planned so that the cable emerges in a protected duct, bends at angles that are generous, and rests in bedding that is soft. Occasionally, you might think about the notion of failure, but here the language is softened. If a component decides it has given enough, it signals. The turbine closes its eyes, so to speak, by feathering blades and opening circuits, and waits without complaint. A note appears on a screen. A plan is made for the next slack tide. The part is swapped. The turbine wakes. There is no drama. There is only continuity. The gentle personality of tidal energy comes from its origin. Gravity does not tire. The moon does not alter its pace to tease. The water does not choose to surprise. It flows in the shape defined by geology and the heavens, a shape that can be drawn and predicted and lived with easily. In a world where many things ask for your attention, this is one that asks for very little. Even in this long rumination, you might find moments where your mind drifts away to other quiet topics, as if the turbine were keeping watch while you wander. That is appropriate. It means you can trust the story to continue without you. The gentle rhythm continues. Sometimes engineers speak of capacity factor, a measure of how much energy a machine produces compared to its theoretical maximum. For tides, the capacity factor is shaped by the coming and going of currents. It is not 100%, and it does not need to be. Like a person who does not speak constantly but says enough, the turbine contributes reliably when it can and rests when it cannot. The net effect over time is pleasingly steady. The world beneath the surface is dim in a way that tissue paper over a lamp is dim. Light filters, milked by the water that has its own texture and color. This softness cloaks the machine in a visual hush. Photographs taken by divers show the turbine as if through fog. Edges are seen but not sharp. The impression is of form and presence without insistence. In such images, the turbine appears to belong because the water has made it part of its own aesthetic. One can move outward in scale to see that tidal energy is a thread in a larger fabric of coastal knowledge. Fishermen know the channel marks and the bottom contours. Kayakers feel the pull and the standing waves. Sailors read the tide tables and plan their passages. Biologists observe spawning cycles tuned to the lunar phase. Tidal engineers add their own layer of understanding, less about light and life and more about flow and force, but still in a tradition of reading the water with attention. The culture is coherent. The values align around patience and respect. Suppose a child on a ferry asks a parent if there is anything underneath the waves. The parent says that there are fish and seaweed and also machines that turn slowly, helping power the lights at home. The child nods and on the next crossing looks down more, imagining the gentle blades. The idea does not frighten the child. It does not thrill either. It becomes an idea that sits quietly among many others, like the knowledge that there is a current in a river or a breeze in a valley or a shadow under a tree at noon. Let your breathing take that steady shape again. A slow, comfortable inhale. A slow, comfortable exhale. Imagine that the turbine turns at that rate, or perhaps 2 or 3 times faster if it needs to, but always with that sense of smooth repetition. The sea presses by. The blade meets it. Energy moves through matter to motion to magnets, to a current in a cable, to a glow in a lamp. The chain is uninterrupted and undramatic. As the story lengthens and the night deepens, your room becomes the quietest part of your world. Outside, things continue. The tide rises. The tide falls. The turbines maintain their watch. The moon drifts along its path. In a few hours, the sky will lighten, and so will your thoughts, as sleep completes its task. For now, you can rest with images of green-gray water, rotating blades, smooth hub, and the polarity of a generator that alternates with the confidence of measurable cycles. There are words that suit this mood: patience, predictability, presence. These are not exciting words, and that is their charm. They describe virtues that help people rest. A turbine that personifies these virtues becomes a kind of bedtime companion, sitting in the dark, doing what it does without asking for you to attend or applaud. It does not show off. It does not stop. It simply works. Engineers sometimes use the phrase design life. For a tidal turbine, this might be 20 years or more. In those years, the machine will see thousands of tides. It will produce an amount of energy that is measurable in terms that reflect human comforts rather than abstractions. It will heat homes through winters that it does not feel. It will drive trains that skim along coasts it cannot visit. It will charge phones that glow in rooms like yours. And then, at the end, it will bow out and either make way for a new machine in its place or leave the spot to the fish and the weeds, who will take no special note of its departure. In the years it runs, it participates in a local economy in small ways that add up. Suppliers deliver bolts and coatings, boats are chartered, technicians gain experience, students write theses. These are quiet benefits that do not spark headlines, but that form a steady underlayment of livelihoods. If you think about this too much, you might find it soothing in the same way that kitchens are soothing, with their steady presence and repeated tasks that lead to nourishment. Even the mathematics of grid integration can feel comforting if you approach it in the right way. There is a matrix of times and places where power comes in and goes out. Storage catches some of it and releases it later. Interconnects carry power across regions. Demand shifts with day and night, with seasons and weather, with human habits that are predictable. Tidal energy sits in this grid like a friend holding a place in line, consistent and reliable, not loud, not impatient, saving a seat for the rest of the ensemble. The gentle blades themselves deserve another visit. Their surfaces are polished to a finish that guides water cleanly. Leading edges are robust, ready to meet the occasional particle carried by the flow. The spar inside has strength that is not flamboyant, yet enough to accept repeated loading through years without cracking. Designers use fatigue curves to ensure that the life of the material is not spent too quickly. The resulting blades feel dignified, like beams in an old house that have been chosen for straightness and then left alone to do their duty quietly. Inside the nacelle, gentle warmth emanates from the generator when it works, a careful balance of loss and gain. Cooling systems carry that heat away to the water outside. Some are passive, using conduction through the nacelle skin. Others circulate fluid through channels that release heat into the sea. It is all arranged so that temperatures stay within the range where materials are happiest, and so that nothing stirs that does not need to. If a pump runs, it does so with the low, barely noticed sound of a fridge at midnight, a sound that many find comforting because it means the world is under control. If you imagine the seabed beneath the turbine, it is a landscape of small and simple features. There are ripples that shift over days, not minutes. There are stones that move only in the strongest flows, and even then they roll with determination rather than speed. There are soft patches and firm patches, shells and sand, and the quiet remains of plants. The foundation's presence adds a slow story to this place. Over time, small changes occur. Over time, people watch and record. Over time, small corrections are made if needed. The scale is human. The tone is gentle. Let your mind step aside now and let the images continue without your active guidance. The turbine turns. The current passes. A ship hums in the distance. A bell marks a buoy's position. A lighthouse sweeps a slow beam. Clouds glide. The moon pulls. The electrons drift toward shore. Inside a home, a lamp glows on a bedside table. A book lies half open. The air is warm enough. Someone sleeps. The gentle rhythm continues. If you are still listening, you can imagine a map of the world's tidal sites. Norway's fjords, Scotland's firths, French coast with their strong ranges, the coastline of South Korea where straits gather water in lines, the channels of Alaska where the sea runs like a large river twice a day. Each site has its character, each with a pace and a direction that changes with the fortnightly breathing of springs and neaps. All share a family resemblance, which is the smooth arc toward predictability. Technology will continue to mature. New blade materials might offer longer lifetimes. New control algorithms might sense eddies a second early and adjust in ways that reduce wear. New connectors might mate and unmate faster to shorten maintenance windows. Each advance will be quiet, like a craftsman improving a technique year by year without changing the look of the final piece. The turbine in your mind will remain the same dignified shape, performing the same tranquil duty, while its interior becomes ever more at ease. As this long, lulling story reaches its closing stretch, you can let go of details and hold on to the theme. A machine exists under the water. It turns slowly. It does its work calmly. It harms little. It gives a little. It blends into routine. It listens to the moon. It does not need attention. It does not need hurry. Its nature is aligned with sleep, which is the unhurried turning of your own inner turbine, the exchange of energy between a fuller and an emptier you, a steady flow that restores instead of depletes. You are safe. The room is still. The bed holds you. The sky outside moves with a pace that has comforted humans for as long as there have been humans. The sea will continue to move whether you watch it or not. The turbines will continue to turn whether you think of them or not. You can let your eyelids fall to half-mast, then close. If you wake later and hear the quiet, it will be the same quiet, still waiting, still kind. Thank you for spending this calm time here. If this gentle visit under the tide has helped you relax, you can softly leave a like and subscribe so we can keep releasing videos this often, and you can find the playlist in the description if you want to keep learning while drifting. Sleep well, rest deeply, and let the tranquil duty of the tide carry you onward.